morning everyone. So in the last class we discussed a numerical in which we found out the normal stress, shear stress, resultant stress and angle of obliquity. Okay. So this question is based on the fully complex stress system which is given as one stress in x-axis, another stress in y-axis and a shear stress along the object. So now comes to another numerical which is the principal tensile stresses at a point across two perpendicular planes are 100 MPa and 50 MPa. Find the normal and tangential stresses and the resultant stresses and its obliquity on a plane at 20 degree with the major principal plane. So now comes to the what are the data givens of the question. So first of all you can see the 100 MPa. It is the first value. So we will take the 100 MPa as the stress in the x-axis. So sigma x will be your 100 MPa. It is positive in nature, so that we can say it is tensile in nature. The next value is your 50 MPa. So it is also positive in nature. That means it is tensile stress. So sigma y equal to 50 MPa. Okay. So another thing is given, the angle which make an angle with respect to the major principal plane. Major principal plane means the 20 degree is directly the value of theta. Okay. So here theta value is 20 degree. So here you can see the shear stress value is missing. So we have to calculate all the stresses like normal stresses, tangential stresses and resultant stresses without any shear stress. Okay. So here tau value is missing. So that we just put up to this formula to this formula. And the part of tau or shear stress is omitted because tau xy is 0 or not given in your question. So that you can see for the calculation of the normal stress we use the formula up to the cos 2 theta. Okay, the first half of the formula is given. So just put the formula as sigma n equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta. So theta is directly given as 20 degree. Sigma x value is 100 MPa and sigma y value is 50 MPa. So just put the formula here and values of each of the terms. So 100 minus 50 divided by 2 plus 100 minus 50 divided by 2 cos 2 into 20 degree. By calculating all these things, we will get the value 94 MPa or you can say 94 Newton per mm square. So next one is your shear stress. So here also tau xy value is missing. So in the previous question the formula of shear stress is this one. So here you can see the tau value is there. Okay. So due to in this question the tau is missing, so that we just put only this portion. That means the first half of the portion we put in this formula and get the value of shear stress or tangential stress. So just put the value, which is sigma x minus sigma y divided by 2 multiply with sine 2 theta. So sigma x is your 100 minus sigma y is your 50 divided by 2 sine into 2 multiply with 20 degree. Hence, we will get the value 16 MPa, which is the value of tangential stress. So now comes to the resultant stress. So what is the value of resultant stress? So sigma R equal to root over of normal stress square plus shear stress square. So your normal stress, we got the value 94 and shear stress, we got the value 16. So root over of 94 to the power square plus 16 square. By calculating this value, we will get the value of resultant stress as 95.4 MPa. Okay. And then we have to calculate the angle of obliquity, or you can say the value of phi. So the formula for phi is tan inverse tau by sigma n. So tau value is 16 and sigma n value is 94. So tan inverse 16 by 94 equal to 9.7 degree. So by this, your calculation part is over. So now it is the time to draw the diagram and show all the stresses like normal stress, shear stress, resultant stress and the angle of obliquity in the figure. So now you can see in the question it is given that sigma x equal to 100 MPa, sigma y equal to 50 MPa and there is no provision of shear stress. Okay, so here tau value is omitted. And then we calculate the normal stress as 94 MPa, which is shown in the figure. You can see this arrow mark represent the sigma n, which equal to 94 MPa. Then the shear stress value is 16 MPa. So you can see this arrow mark, which is inclined in nature and parallel to the oblique plane, it is 16 MPa. The next one is your resultant stress, which is tau r, which equal to 95.4. So you can see this red color arrow mark, it is represent the resultant stress, which is 95.4 MPa. And last is your phi, which equal to 9.7 degree. So this is the angle which is indicated here. This angle equal to your 9.7 degree. So by this, your calculation or numericals based on complex stress system is over. So now I will give you some assignment questions. So this is your assignment question. Your assignment question is based on 4 kinds of questions which based on principal stress and strain system. So this is all your assignments. So complete it. Okay. So in this question, look at the second number question. Here, the stresses are given in x direction, which is your first value 200 MPa is tensile in nature and second value, which is 100 MPa, is compressive in nature. So that you have to take sigma x equal to 200 MPa and sigma y equal to minus 100 MPa. Minus sign we provided due to the compressive nature of the stress system. Okay. So you have to calculate carefully and take the value of sigma y due to the compressive stress as negative sign, and then you can calculate your value of normal stress, tangential stress and shear stress also. So thank you so much. Today this much. We will discuss another thing in the next class. Thank you.